Immunology Insights, Basics and Beyond. Chapter 18, The Inflammatory Response. Marcello here. Welcome back to Immunology Insights, Basics and Beyond. In our last chapter, we explored the pioneering work of Paul Ehrlich and his side chain theory, which laid the foundation for our understanding of how antibodies function. Today, we will delve into a crucial aspect of the immune reaction, the inflammatory response. This complex process is essential for the defending of the body against infection and injury, but when dysregulated, it can also contribute to a wide range of diseases. So let's talk science. To introduce inflammation. Well, inflammation is the body's natural response to injury or infection. It is a protective mechanism designed to eliminate the initial cause of cell injury, clear out damaged cells and tissues, and establish a repair process. The inflammatory response is a critical component of both the innate and adaptive immune systems, playing a central role in the body's ability to heal and defend itself. Inflammation can be acute or chronic. Acute inflammation is the immediate and early response to injury or infection. It is characterized by the rapid influx of immune cells, such as neutrophils, and the release of pro-inflammatory cytokines. Acute inflammation typically resolves once the harmful stimuli are removed and tissue repair begins. Then we have the chronic inflammation. When inflammation persists over a longer period, it becomes chronic. Chronic inflammation is often associated with the continuous presence of the causative agent, ongoing immune response, and tissue destruction. It is a feature of many chronic diseases, including rheumatoid arthritis, arteriosclerosis, and certain cancers. The inflammatory response can be divided into three overlapping phases: initiation, amplification, and resolution. Let's first start with the initiation. The inflammatory response begins when immune cells such as macrophages and dendritic cells detect injury or infection through pattern recognition receptors or PRRs, like the toll-like receptors or TLRs. These receptors recognize pathogen-associated molecular patterns, also called PAMPs, on microbes, or damage-associated molecular patterns, also called DAMPs, released by injured cells. This detection triggers the release of pro-inflammatory cytokines such as tumor necrosis factor alpha or TNF-alpha, interleukin-1 or IL-1, and interleukin-6 or IL-6, as well as chemokines that recruit neutrophils and other immune cells to the site of infection. Second, we have the amplification. As immune cells arrive at the site of inflammation, they further amplify the inflammatory response by releasing additional cytokines and chemokines. Neutrophils are often the first responders, followed by monocytes that differentiate into macrophages. These cells work to phagocytose or engulf and digest pathogens, dead cells, and debris. The complement system is also activated, enhancing the ability of phagocytes to clear pathogens and contributing to the formation of the membrane attack complex or MAC that lyses bacteria. Third, we have the resolution. Once the harmful stimuli have been eliminated, the resolution phase begins. Anti-inflammatory cytokines such as interleukin-10 or IL-10 and transforming growth factor beta or TGF-beta are produced to dampen the inflammatory response. Macrophages shift from a pro-inflammatory to a reparative role, helping to clear dead cells and promote tissue repair. The resolution of inflammation is crucial for preventing chronic inflammation and restoring tissue homeostasis. What are the signs and symptoms of inflammation? The classic signs of acute inflammation are often summarized by the Latin terms calor, which means heat, rubor, which means redness, tumor, which means swelling, dolor, which means pain, and functiolesa, which means loss of function. These signs are the result of the physiological changes that occur during inflammation. Let's have a look in detail. Heat and redness are caused by the increased blood flow, or hyperemia, to the inflamed area, which delivers more immune cells and nutrients to the site of injury or infection. Second, we have swelling. Fluids, immune cells, and proteins accumulate in the respective tissues. Also, the blood vessels become more permeable to allow immune cells to enter the affected area. This increase in permeability helps the immune components to reach the site of inflammation more efficiently. Third, we have pain resulting from the release of inflammatory mediators such as prostaglandins and bradykinin, which sensitize nerve endings and increase pain perception. This pain serves also as a protective mechanism, discouraging further use of the affected area to prevent additional injury. Fourth, we have the loss of function. It occurs when the inflammation is severe, leading to tissue damage and impaired function of the affected area. This can also be a protective response, as restricting movement may allow a more efficient repair and healing. Now let's look at the relation between fever and inflammation. Fever is a systemic response often associated with inflammation. It is triggered by pyrogens such as IL-1 and TNF-alpha, which signal the hypothalamus to increase the body's temperature. This elevated temperature enhances immune efficiency by optimizing enzymatic reactions involved in immune responses, reducing pathogen replication and improving the activity of phagocytic cells. Fever can therefore be seen as an extension of inflammation, enhancing the body's defense mechanisms. However, if fever becomes too high, it can lead to cellular damage, seizures, and even organ failure, as excessive heat disrupts normal protein function and cellular processes. In some cases, fever regulation fails due to overwhelming infections or sepsis, autoimmune diseases, or defects in the hypothalamic control. Of course, inflammation has a role in various diseases. While inflammation is essential for defending the body and promoting healing, dysregulated inflammation can contribute to the development of various diseases. Chronic inflammation in particular is a common underlying factor in many chronic conditions. As first example, we have autoimmune diseases. In autoimmune diseases, the immune system mistakenly targets the body's own tissues, leading to chronic inflammation and tissue damage. This misdirection often occurs due to genetic predisposition and environmental triggers that cause the immune system to recognize self-antigens as foreign. The second example are cardiovascular diseases. Chronic inflammation is a key contributor to the development of arteriosclerosis, where inflammatory cells accumulate in the arterial wall, leading to the formation of plaques. These plaques develop due to prolonged immune activation triggered by oxidized lipids and endothelial damage, which can result from high cholesterol levels, smoking, or hypertension. This damage leads to chronic immune activation, plaque formation, and potential vessel blockage. As third example, we have cancer. Chronic inflammation can promote the development and progression of cancer by creating a microenvironment that supports tumor growth and metastasis. The respective inflammation can arise from persistent infections, for example by Helicobacter pylori in gastric cancer, autoimmune responses, or long-term exposure to inflammatory stimuli such as tobacco smoke and environmental toxins. These factors lead to continuous immune activation, DNA damage, and immune suppression, allowing cancerous cells to form and to escape detection. As fourth example, we have neurodegenerative diseases. Inflammation is increasingly recognized as a factor in neurodegenerative diseases, such as Alzheimer's disease and Parkinson's disease. In these conditions, chronic inflammation in the brain leads to neuronal damage and accelerates disease progression. Of course, there are also therapeutic approaches to inflammation. Given the central role of inflammation in many diseases, anti-inflammatory therapies are a cornerstone of treatment. These therapies target various aspects of the inflammatory response. We have first non-steroidal anti-inflammatory drugs, or NSAIDs. These drugs, such as ibuprofen and aspirin, inhibit cyclooxygenase or COX enzymes, reducing the production of pro-inflammatory prostaglandins and thus alleviating pain and swelling. Second, we have several biologic agents that target specific cytokines involved in the inflammatory response. For example, TNF-alpha inhibitors such as infliximab and etanercept block TNF-alpha activity, reducing inflammation in conditions like rheumatoid arthritis and inflammatory bowel disease. Third, we have corticosteroids that suppress broad immune activity by inhibiting transcription factors like NF-κB, reducing the production of inflammatory mediators but also increasing susceptibility to infections. And fourth, of course, also lifestyle interventions are crucial. A healthy diet rich in anti-inflammatory food, for example omega-3 fatty acids, fruits and vegetables, regular exercise and stress reduction techniques have been shown to help regulate inflammation and lower the risk of chronic diseases. Anti-inflammatory therapies are crucial in preventing disease progression and mitigating symptoms by controlling excessive immune activation that can cause long-term damage. To conclude, the inflammatory response is a double-edged sword, essential for protecting the body from infection and injury, but potentially harmful when it becomes dysregulated or chronic. Understanding the mechanisms of inflammation and how they contribute to both health and disease is crucial for developing strategies to manage and treat inflammatory conditions effectively. As we continue to explore the complexities of the immune system, it's important to recognize the delicate balance that inflammation plays in maintaining health. While acute inflammation is protective and necessary, chronic inflammation can lead to a wide range of diseases, highlighting the importance of regulating the inflammatory process. In the next chapter, we will delve deeper into specific immune mechanisms and responses, especially the mechanism and role of phagocytosis, further uncovering the intricate interplay between the components of the immune system. Stay with us as we continue to explore the fascinating world of immunology, where each process, no matter how small, contributes to the larger picture of health and disease. Before closing, I have a small request. If you enjoyed my content and want to hear more, like and subscribe. It's a small step for you, but it helps me a lot. So, see you next time and thank you for listening.